Say you're looking at two equations at once, a system of simultaneous equations, we called it before, and you're looking for values of x and y that will satisfy both equations at once. You already know how to do that, right? You graph the one equation, then you graph the second equation on the same set of axes, the same sheet of graph paper if you want to think of it that way. Find the point where the two lines intersect, read off its x and y coordinates, and you have your answer. That's great if the coordinates are 1 and 2, but it's not so great when there are large numbers in your equations, or when your coordinates are fractions you can't even read on a graph. So you need another method to back you up when graphing doesn't work. Is there another way? There is. It uses a special kind of substitution and no graphing at all, just algebra. Here's a system of simultaneous equations in two variables, just what we need. We'll solve it with no graphs in 4 steps. Step 1. Pick an equation and solve it for one variable. In other words, treat it like a formula and solve it for one letter in terms of the other letter. Which letter do we pick? We could pick any of them, but most would give us fractions, so we pick the lonesome y because it has a coefficient of 1. It's going to give us the simplest formula, and that formula will be the key to the whole process. We solve for y and get our key formula. Y equals 11 minus 5x. That doesn't give us the numerical value of y, but it's still very important because we're going to use this key formula 2 more times, and then we'll have solutions for both x and y. In step 2, we take this formula and substitute it into the other equation. That's why the method is called substitution. Since y equals 11 minus 5x, we write this expression into the equation in place of y. And just look at what that gives us. Suddenly, an equation in just one variable. No problem with that. We just keep right on going until we have a value, a real numerical value for x. It's a fraction, and we couldn't have read it from a graph. And then guess what? We can take that value and substitute it back into that key formula we got in step 1. Remember, the answer in step 1 was y equals 11 minus 5x. But now we know what x is. So we substitute the value of x into the equation and immediately find ourselves swimming in a sea of fractions. If we handle them right and survive, we get the real value for y. And again, it's an answer that we couldn't very well get from a graph, 18/13. We already found x, now we found y. So that's it. We have our answer. As usual, we could check it by substitution, but it wouldn't be easy. Much better to get it right the first time. And we did. 4 steps. First, find the key formula, an expression for one variable in terms of the other. Second, substitute your key in the other equation. Then work out the equation to a final answer, and finally put that answer back into the key and get your second variable. Can you do it? Of course you can, and here's your chance. Turn off the tape and go through the 4 steps to find the answer. Step 1. I start by solving for that lonesome x with the coefficient 1. That's a cinch, and it gives me that important formula I'm going to use 2 more times. I substitute that value into the other equation, and that immediately gives me an equation in one variable, which I can take all the way to a final answer for y. In step 4, I go back to that key formula from step 1 again and substitute the value of y, 9/19, for the y in the equation. Once again, an equation in one variable. And now I work out the fraction for x. Did you get it? I hope so. If not, don't worry. A little practice will make a big difference. You can get started right away on this word problem. Go ahead and use x and y for your variables, and be sure to translate the problem into 2 equations before you begin. Then use the 4 steps, get your answer, and come back. I use x for the cost of gas and y for the cost of oil, and translate the whole thing into algebra. A simultaneous system of 2 equations, which looks like this. I don't find any coefficient 1 this time, so I can't avoid getting fractions in the first step. But I keep the fractions as small as possible by choosing the 2y to work with. I choose the 2y and use it to find that key formula. I'm going to use that formula 2 more times, and then I'll have the final answer. Step 2, I substitute the key answer into the other equation. Substitution first, and then simplification. Then I want to get rid of that fraction. So I multiply both sides by 2. Simplify some more, and get a final value for x, 1.5. Then I go back to my key formula, substitute the real value of x, which I just found, and that gives me the value of y, which completes the answer. So my final answer is $1.50 for gas and $1 for oil. If you thought the arithmetic was a little harder here, you were right. The reason? No variable had a coefficient of 1, so we had to deal with fractions. Good news. The module on solving systems by elimination offers another technique that often helps in a case like this. For now, look up some more examples and be sure you know how this method works. Then do some more problems, and then a few more, until getting them right becomes a habit. You'll be glad you did. And good luck.